I've inspected this Seth Thomas movement on a previous video and found that over 90% of the gold gilt has been damaged in the past. The exposed brass on the movement is suffering from surface dezinctification. Reactive metals like copper next to zinc can begin to oxidize. This movement has an excessive amount of oxidation on it. If removed by mechanical means, this could involve using steel wool, abrasive papers, and compounds. These will remove oxidation but also will remove a portion of existing brass from the movement. I've decided to use a chemical removal process. I'll be using one of the same chemicals found in common brass polishes. Brass polishes have abrasives in them. I don't want to use any abrasives on this movement, so I'll use my own mix of cleaner without the abrasive powders. Vinegar and salt mixed together make an excellent brass oxidation remover. It needs to be followed up with a baking soda rinse to neutralize the parts. To the vinegar, I add table salt. Then stir the two together. Mechanical cleaning would also remove any remains of gold gilt. I want to preserve as much of the gold as possible. It forms a solution of hydrochloric acid. Each part needs about 2 minutes in solution to remove the oxidation. Then into the baking soda. I ended up mixing the baking soda with some water and let each part soak for several minutes in the mix. Followed up with a blow dry from my air compressor. Once the parts are deoxidized, they'll have a copper color to them where the oxidation was removed. You can see the small amounts of gold gilt patches. The gold wasn't removed by the acid. This is a good thing. Next step is to brush the part with a soft brass brush. There are a lot of brass brushes out there. Some of them are just too stiff for the finish I'm looking for. I use an old suede brush. It has nice soft bristles and it's gentle on the parts. There seems to be a transfer of brass from the brush to the copper on the parts. In a short time, the part surface will take on a brass finish. While brushing the brass, I also brush the steel shafts. They also take on a polished finish. But we'll still need to run them through a final clean. I'll get busy brushing. Now these look great. It's not the same color as gold gilt, but it brings back some luster to the parts that were lost with the oxidation. They almost look like they were run through a cleaning machine. Looking good so far, much better than the black oxidation. Next step is to begin to repair any mechanical defects on the movement. The pivots on the verge need to be polished. It's unpractical to disassemble the verge for this, so I'll use an alternate process to polish them. Polishing compound used with threads and strings work great for this. Now that's a nice finish. Some of the pivots need to be stoned to remove tool marks. This stone works good for this. Once stoned, I follow up with several grits of silicon carbide paper, from 400 grit up to 2000 grit, using a flat piece of glass. Clean the pivot between each grit of paper. Then with a polishing compound on a hardwood slip, bring it to a mirror finish. This pivot almost looks like someone took a pair of side cutters to it. Going to need to be stoned before any polishing is done. Using a black felt pen makes it easy to know when the stone is in full contact with the pivot surface. When the polishing compound on the wood turns black, you know it's doing its job at cutting a small amount of steel from the surface. Now that all the pivots are polished, it's time to check and see how many bushings will be needed. I found this wheel has a bent gear. Wow, it's really bent quite far out of alignment. I'll remove all the others so I can see it rotate by itself. And the center shaft isn't running true either. It has a bent pivot. I'll attempt to straighten the pivot first. It's not going to be perfect, but it'll be close. I'll use this dead center to get it as close as I can. That looks fair. Now to deal with the gear wheel. The indicator I mounted to the tool post helps to see where it needs to be tweaked. I'll use 2 pliers, one to hold the wheel firm and the other to tweak the wheel until it's acceptable. This looks much like the others now. Time for bushings. Each egg-shaped hole needs to be filed out round and concentric to the oil sinks in the plates. I'm not going to remove all the damage next to the pivot holes. I'll remove just enough materials to install each bushing. Time to ream the hole to prepare it for the bushing. I drill each bushing with a drill bit just a little bit smaller than each pivot. Here it is in the raw. Now to press it into the plate. Good, nice snug fit. Now to ream it to size it to the pivot. And to do a fit check, someone filled this pivot hole with solder. Not the best repair practice any customer wants in their clock. Now to assemble it to see how they all work together. I've cleaned the movement and applied a clear urethane finish to all the parts. This will protect the brass from any future oxidation. Urethane is a lot more durable and solvent resistant than the traditional lacquer or wax used in the past. Everything is coming together great so far. Once the rubber bands are in place, all the pivots can be gently nudged into place with minimal clamping pressure on the plates. Pull these mainspring clamps out. Oil it up. Now it's time to deal with the hinge on the bezel. You can see the dial pan is held in with solder. This looks like oil. I'll wipe it clean. I see the solder on the hinge broke loose. Now that looks much nicer. It's not going anywhere now. Ah, and it works great now too. The movement has been running flawlessly for over a week on the test stand. Time to mount it in the case. This wire sticking out here is to be used when transporting the clock. All working just fine so far. On the half hour, the bell sounds off. On the hour, the gong strikes the hour. Nice sounding clock. Time to contact the customer on this one.